Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10 or 7/10. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. Let's rewrite this expression, but with a time sign in, so v times w squared. Now w squared just means times by itself, so we can rewrite that as v times w times w. Okay, so we know v is minus 10, so minus 10. And we know w is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. First thing we need to do is work out the area of the wall. And so to do that, we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it'd be 176 times the 5.7, or £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1003.2. And so as money, that would be £1,003.20. The lowest point on this graph is here, and that's at 0.6, and the highest point is here at 0.20. And we're looking for percentage change or percentage increase, and the formula is change over original times 100. So the change between the 6 and the 20 is 14. The original, the starting point, was the 6, and times by 100. And that gives us 233.333 blah 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 %. And this 100 technically is 100% that we're timesing it by. So it says it wants it to the nearest percent, so that would be 233%. The area of a trapezium is found using the formula area equals half A plus B times H. Now A plus B are quite easy to find because they are the parallel sides in the trapezium, which are these two. It doesn't matter which way around we label them. I'm going to say A is the right hand one and B is, or left hand one, and B is this right hand one. Then H always hits A and B at 90 degrees. So if we have a look at some of these lengths, this length at the top here is touching the A and B at an acute angle for A and an obtuse angle for B, so that is definitely not the height. This length here, same thing. It's hitting the A at an acute angle and B at an obtuse angle, so that is not the height. The height is actually going to be this length here, because you can see it hits both A and B at 90 degrees. So let's fill this into our formula. So it's going to be half times A, which is 8.7, plus B, which is 5.3, and then times that by the height, which is 2.4. That's going to be half times 14 times 2.4. That's going to be 7 times 2.4, and then that will be 16.8. All the units in the diagram are in centimetres, so our area will be centimetres squared. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in twos. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. For this question, it's really useful to label angles that you know on the diagram, even if you can't go straight to the answer. So I know that if I extend this line here, but let's do a bit of a better job of that. So if I extend this line here, the north line, then I can work out what this angle is, because it's going to be the same as this angle here. And the reason is it's Z angles, which are alternate angles. So I know that this angle is 35 degrees because of alternate angles. The question asks to find the bearing of C from B. So we're at B and we're finding the angle that C makes from north going clockwise. Well, it's going to be this angle here we're looking for, and if we look, we already know what this side is, which is 180 degrees because it's a straight line. We've got the 35 degrees there, and we've got the 21 degrees. So it's going to be 180 plus 21 plus 35, it doesn't matter which order we add them, which will equal 236 degrees. A plane of symmetry is anywhere you can cut a three-dimensional shape, in this case a cuboid, and put it up against a mirror and it looks like the original shape. So if we were to cut the cuboid here and then put it up against a mirror, it would look like the cuboid again. Similarly, if we were to cut it along here, it would look like the original cuboid again. And finally, if we were to cut it up the top here, down, across the bottom here, and then up here, and put it up against a mirror, it would look like the original cuboid again. Now you might think that diagonal ones will work with this. Diagonal ones only work with cubes, not cuboids. So our answer is 3. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into and they all have to be the same length, that will fit with the 25 metre and the 35 metre. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1, 25, and 5, and 5, and the factors of 35, which will be 1 and 35, and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 metre pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 metre long, and there's no wastage, and that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 metres. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chilton, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chilton to Devley is 34 miles. Distance from Devley to Bovlo is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chilton at 9 o'clock. He drives from Chilton to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes, or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed, distance, time triangle. So speed equals distance over time, and we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that would be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing, it's timesing the x by minus 6. So I'm going to divide both sides by minus 6. So that gets rid of the minus 6 on the left hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. With these questions, what we need to do is write down what we're given in the question. So it says that the car accelerates at 6 meters per second squared. So we got the acceleration, which is 6 meters per second squared. And I'm using the same letters as it has in the question here. It says for 21 seconds, so we've got the time, which is here. So the time is 21 seconds. Now, there is also something else it gives us, because it says from rest. So the initial velocity is going to be 0. And it asks us to find the final velocity. So we're looking for what v is. So we're looking to see which of the 3 formulae at the top involve an a, a t, a u, and a v. So it's not going to be this one because this has an s. It's not going to be this one because this has an s. It's going to be the top one. So what we do is we write down the top one. V equals u plus at. And we're looking for v, so I'm going to keep v as a v. U is 0 plus a, which is 6, times t, which is 21. 6 times 21 is 126. Obviously 0 plus 126 is just 126. The units are meters and seconds throughout, so it's going to be 126 meters per second. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side. And we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So we've got a right angle triangle and we're given 2 lengths and we're asked to find a 3rd length, and that means we're going to be using Pythagoras' theorem. And to do that, we're just going to label the sides A, B and C, and C must be the hypotenuse, which is opposite the right angle. Pythagoras' theorem says that a squared plus b squared equals c squared. A we can see is 3.4, B is 5.2. And we're looking for what c squared is. So 3.4 squared plus 5.2 squared is 38.6. And we need to solve to find out what c is. And to do that, what we do is we just square root both sides. So square root of 38.6 is 6.212 blah blah blah. And c squared, the square root of that is c. So it's 2 decimal places, it's going to be 6.21. When proving that 2 triangles are congruent, and congruent just means exactly the same, there are 4 different proofs. Either you can work out the 2 angles and a side in that order, or an angle, a side, and an angle in that order are the same. A side, an angle, then a side again are the same. 3 sides are the same, or we've got right angle, hypotenuse, and side. Now in this question we don't have a right angle, so we can get rid of that. We have a side but only 1 side, so we're not going to use the 3 sides. And again, we don't have 2 sides, we only have 1 side, so we can get rid of this one. So it's really down to the top one. Well, what do we have? We have an angle, then a side, then an angle. So it's 139 degrees, then 13 meters, then 49 degrees in that order. So it's an angle, side, and then an angle, side, then an angle. So it's going to be this one here. So we're going to say ASA, or we could say AAS stroke ASA, or just leave it as ASA. I probably would leave it as ASA to say it's the angle, side, angle. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line, and we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995. And the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that v can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. First thing we notice with these simultaneous equations is the coefficients of the x and the y's are different. But if you look at the y's, there's a minus 3 here and there's a plus 6 here. So all we need to do is times the top one by 2 and they'll both be 6, and we ignore the signs. So we're going to quickly multiply everything in the top by 2 to make the coefficients of the y's the same. So we're going to times that by 2, times that by 2, and times that by 2. So we get 6x minus 6y equals 30. So I'm just going to write that in again. So 6x minus 6y equals 30. And I'm going to write in the second equation underneath, because that's how we do it with simultaneous equations. Now, simultaneous equations, we work downwards. So I'm just going to show circles showing that we're going downwards here. And what we want to do is have a look at the signs for the y's, because we made the y's the same, and if they are the same sign, we're going to subtract. If they are different signs, we're going to add. Well, we've got a minus and a plus, so they are different signs, so we're going to add. And I'm going to work out the sums. So 6x plus 4x is 10x. Now this is a crucial bit. minus 6y plus, which is just a plus, 6y is 0, and that's why we added to get rid of the 6y's. 30 plus 10 is 40. I'm going to just solve that. So we're going to divide both sides by 10, and we get x equals 4. Now that's one of the solutions, but we've got to find out what y is as well. So we're going to look at this first equation here, and we're going to just write out that, but substituting in the 4. So it's going to be 3 times 4 minus 3y equals 15. Get our solving lines in. So 3 times 4 is 12, so we're going to take away 12 for both sides. So we've got minus 3y equals 15, take away 12, which is 3. And then we're going to divide by the minus 3 both sides. So it's going to be y equals minus 1. And we can check this by substituting the x and y into the second equation. So 4 times 4 plus 6 times minus 1, which is equal to 10. I'm going to first of all draw the two triangles out separately. And we've got A, B, C, and then A, D, E. And the first thing to notice is we have similar triangles here, and the way we know that is that we've got an F angle here, which means they're corresponding on the two parallel sides. So these two angles are the same. We've got exactly the same thing on this side. We've got F angles, so these two are corresponding. And then the top angle is shared between the two triangles. And when you've got two triangles with exactly the same angles, they are going to be similar, which means one's an enlargement of the other. I'm just going to put on the length that we've got. Now we're looking for quite a complicated one. We're looking for the length CE, which is this one here. Now I can't actually label that onto my two triangles, but what I do know is that CE is equal to AE minus AC. Now we know what AE is, which is 60. So we just need to find out what AC is, this one here. And when we find out what AC is, we can just take them away to work out what the CE is. So we need two corresponding lengths that we know both of them. So we've got the 9 and 36 here. Because these two triangles are similar, we know that we can work out what the scale factor is. And to work out the scale factor, you do big divided by small. So 36 divided by 9. And we work out that that is going to be 4. So we know we're going to have a scale factor of 4. So to get from the smaller triangle to the big one, we times it by 4. But here we have the one, we need to find out what this one is. So one corresponding is this one. We're going from the big to the small. And so to work out from the big to the small, we've got to divide it by the scale factor. So divide it by 4. So 60 divided by 4 is 15. So we know what this one is. So AC is 15. And so we're going to do AE, which is 60. Take away the 15. And that will tell us what CE is, which is 45. So our answer is 45. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.